Last week we started learning about logarithm. So, what is a logarithm? Tells you right there. The logarithm, abbreviated log, is the inverse of the exponential function. And what we did last week is we took things in exponential form and changed it to log form, and we took things in log form and changed it back to exponential form. We changed it back and forth from one form to another. And that was on the salmon colored worksheet, and if you haven't finished that, you need to get that done. And let me point out what it says right there. This n right here cannot be a negative number. A positive number, even 0, but this cannot be a negative number. Please underline that on your notes. Okay, so this is a review of what we did on the salmon-colored paper. Using the definition, how do you change from from exponential form into log form? Well, what's the base of this? The base is 10. The base of the log will also be 10. What's the exponent? The exponent is 3, and so this is where the 1,000 goes. Log base 10 of 1,000 equals 3. Most of the time, though, you will see this written log 1,000 equals 3. If the base is not written, it is base 10. Base 10 is called the common logarithm because it is the one most commonly used in science. So if there is not a base written, the base is 10. When you look at your calculator, and right here on the calculator it has a log button. On this calculator, there's a log button on the blue calculator also. This log button on this calculator or the blue calculator is base 10. If you take the blue calculator and put log of 1,000 and put in enter, it'll tell you the answer is 3. That means 3 raised to the third power is equal to 1,000. But you can't do this problem. Well, let me write it down this way. On the next problem, what is the base? And what's the exponent? So that's equal to 2, and this is a 49. You can't do this problem with the calculator because it's base 7, not base 10. The only kind of problem I can do with the calculator is base 10, or also there is a base E, but we're not going to cover that. You'll talk about that in pre-cal. Please remember that this 7 is called a subscript. It's smaller and it's down. The rest of these are just regular numbers. That's all we're doing is changing from one form to another. And so the first thing we need to know is what is the base. But this one doesn't have a base. If the base is not written, the base is 10. And so this is base 10. You could actually do this one with your calculator. The base is 10. This is the exponent, and it's equal to the 100. Sometimes this little circle helps people remember this. Base exponent equals 2. Base exponent equals 2. I'm not asking you whether or not these are true or false. I'm just asking you to change from one form to the other. Now I'm going to start asking you to evaluate. Evaluate means figure out the answer. What is this equal to? Well, what's the base? 2. I'm figuring out the exponent to make it equal to 8. Do you remember that 8 is 2 to the third power? So what is x equal to? So you change it so that the bases match. That's what you did an excellent job on your test last week. So I know most of you know how to do that. So the expression is equal to 3. Evaluate the expression. What is this equal to? Well, what power am I going to need to make 7 equal to 49? 7 squared is equal to 49. You agree with that? But that's not what we're trying to figure out. We're trying to figure out 1 over 49. And a negative exponent is equal to a reciprocal. That is the definition of a negative exponent. Evaluate means figure out what the exponent needs to be. And then we have some equations to solve. So if it's in log form, to solve it, I'm going to put it in exponential form. If it starts out in log form, to solve it, I am going to put it in exponential form. So what's the base? Base exponent equal to 9 to the third power equals 2x. You can put 9 to the third power in your calculator. I also put the chart back up here, and so you can look at the chart and see that x would be equal to 729. 9 to the first power, 9 to the second power, 9 to the third power. Or you can put it in your calculator. Base exponent equal to. Base exponent equal to. Now that it's in exponential form, that's the kind of problem that everybody did wonderful, not everybody, but almost everybody did wonderful on a test with this kind of problem. And so you have to change it to the same base to solve it. Now, few people did this kind of problem like this. They said, I know that 81 is equal to 9 squared. Is that the same base? You can't solve it unless it has the same base. It is a true fact, but it doesn't help you solve it. So what we need to do is find 3 and 81 in the same column. So we're going to change it to base 3. 1, 2, 3, 4. Sorry. So 81 is 3 to the fourth power. That's equal to 81. I have to change it to the same base. So if the bases are equal, then the exponents have to be equal also. So x has got to be equal to 2. So if it's in log form, I'm going to change it to exponential form in order to solve it. Uh-oh, I don't have a base. If the base is not written, the base is 10. Base 10 exponent equal to. Base 10 exponent equal to. What is 10 to the third power? 1, 2, 3. Or you can put 10 to the third power in your calculator. Hopefully, once you get it to this point, it's very easy to solve. Add 10 to both sides. Divide by 5. Now, you see that I didn't have to match any bases on this one. It depends on where the x is in the problem, what you do after you change it to exponential form, what you do to solve it. And so on this one, what's the base? base exponent equal to. Again, this one, the base is in yet another place. This is a throwback problem. We did this kind of problem a couple of months ago. We are solving for y. In order to solve for y, we have to get the 1/3 exponent out of there. How? Any guesses? Anybody brave enough to guess? We are going to have to raise it to the reciprocal power. Raise it to the opposite power, the reciprocal power, so that that cancels out. So that would be equal to 4 to the 3rd power. 4 to the 3rd power would be 64. You know how to raise something to the power with your calculator. Or you can look on the chart when I put it back up here. As we have done a time or two before, though, if it's not just one log, if it's more complicated than that, before we change it to exponential form, we need to isolate the log. Have we heard the word isolate before? So we are going to isolate the log. So what are we going to do with the 22? Cancel out the 22. Once again, we need to isolate the log. The 2 out in front is multiplied by the log. What's the opposite of multiply? And so we're going to divide by 2. Then when you get the log by itself isolated, then you change it to exponential form. Base exponent equals 2. And then with your calculators, or if you don't know that math fact, 3 raised to the 4th power is 81. Now, the next problem isn't even labeled problem number 12, it's labeled problem number 10. Mark out problem number 10 and mark out the problem also and change it. There was a typo. Mark out the 10, mark out the whole problem, and rewrite the new problem, please. Rewrite this problem, please. 2. Solve this, I need to isolate the log. Isolate the log, I need to get it 1 log by itself, so what am I going to do with the 10? Subtract 10 from both sides. Once you have it down to 1 log all by itself, then you change it to exponential form in order to solve it. Base 2, this is the exponent, equals to x. Well, what is 2 to the 3rd power? You never leave the answer in that form. What is 2 to the 3rd power?